I'm going to discuss rotation and scaling of polygons. For this discussion, here I use a C programming code. Now I have to assume that you have basic understanding about C programming. So let's look at these two lines of code. stdio.h and conio.h. These two are header files. Actually, purpose of including these two header files to our program is to include functions related to input and output. Then the next one, we include another header file math.h. This includes mathematical functions to our program. The last one, okay, the last one, grap.h. This is a user defined header file. Actually, purpose of this one is to include graphics functions to our program. Now let's look at these three lines of code. Yes, double x24, we have declared a two-dimensional array. Another one, y24. Okay, third line, actually it should be int points. Okay, int points 2. Now since we study rotation and scaling of polygons, in this particular code, actually I have used these arrays to store coordinates of two squares. Let's for an example, let's take those two squares like this. Okay, squares or rectangles. Okay, anyway, now here I give index of this square is 0, index of this square is 1, and here we have 4 vertices, and we represent the square using its vertices, and this one 0, 1, 2, 3. This one also we have 0, 1, 2, 3. Now this points variable, points 0 means the number of vertices in our spheroid square. Later we will put 4 here. Later we will do that. And if you consider this one, points 1, that is, here also we have 4 vertices. Later we will assign values. So for the time being, you understand the purpose of this array. Okay, now here we have declared two-dimensional arrays. Now for an example, if you want to store the coordinates of this vertex, okay, let's say coordinates of this vertex is 20, 40, for an example. Okay, just for an example. So in that situation, so you have to consider this is our spheroid square. Its spheroid vertex coordinate is 20. and now y, this is our zeroth square, zeroth vertex, it is 40. Okay, in that way we can do that. Just for an example, another example, just an example. Okay, so here let's say coordinates of this vertex is this one. So how can we store that? X, this is index of this one is 1, and second, the vertex index is 2. Here you put 350, and now y, this one, okay, this one 1. Now vertex number is 2. You here put this value. In that way we can store using these two-dimensional arrays, we can store these vertices. And now if I summarize, if I put x some value here, y some value here, you put the coordinate value, y some value here, some value here, you put value here. Okay, it is something like this. Now here what we include, this one, these numbers. Okay, that means the index of polygon, index of polygon, and here we include this one, this one, this one, or something like that, index of vertex. Okay, it is something like that. Now let's move here. Now let's try to understand this particular function. Now here in dpx, okay, int dpx double x, we have just I will write the body as well, since very short body. Okay, since we have very short body, I just write down that one as well. X plus 0.5. Now here we return p. Now purpose of this one is, if you put a fractional number dpx 17.335, okay, so if you put this one, this function will return 17. Okay, this will return 17. If you put this, will return 18. Okay, that means the purpose of this function is to return the nearest integer. We pass a fractional number here, this function will return the nearest integer to it. Okay, so if you try to understand the concept logically, let's say we have 3 and 4 here. Now always if you pass some number, now let's say here in the middle we have 3.5. okay, so if we pass a number in between these two, okay, so if you pass a particular number, let's say this number, then this in this part it will add 0.5. Adding 0.5 means it will come to here. The new position is here. Then we, using this part, we discard the decimal part. We take only the integer part of the number. For an example, if this is 3.2, here we add 0.5 to it, then it will become 3.7, and using this part we typecast, the fractional part will be discarded, so we get 3. Okay, so in the same way, now what happens, same logic you can apply any number between. If we what happens, now let's say if it is 3, what happens, 3 plus 3.5, 3.5, when we discard the fractional part you will get 3. That means actually the purpose of this function is to round a given fractional number to its nearest integer. If it is 3, it will become 3.5, then fractional part is discarded and the number is 3. So 3, if we round 3 to its nearest integer, it's 3. Now what happens if it is 3.5? 3.5, we add 0.5, 4.0, discard the fractional part, it will become 4. That means 3.5 will be rounded, its nearest integer is 4. In mathematics, you know, you round 3.5 to 4. Okay, same thing you can achieve using this function. Now the logic again, now if you put some number somewhere here, then if you put a number somewhere here, then if we add 0.5, this amount you add to this number, okay, then you get a number somewhere here. Okay, so 4 point something you will get. 4 point something you will get if you pass a number somewhere here. Then if you discard the fractional part, you will get 4. Okay, so now you have to understand it in this way. So let's say we have 3.7. 3.7 we pass, then we add 0.5 to it. 4.2, then discard the fractional part, you will get 4. Okay, so now the purpose of this function is when we pass a floating point number, this function will return the nearest integer to it. Okay, actually purpose is to round the fractional number. Now let's look at the next function. Before that, I want to tell you something. Now this is our screen. let's say this is the display. Okay, in this particular when I use this particular C programming code, in the environment origin was here, okay, in the graphics environment. That means now graphics display is something like this, no? So you have rows and columns, not like this, large number of rows and large number of columns. Okay, it's something like this. One particular cell, we call it a pixel. I hope you are already familiar with these things. Okay, our graphics display screen is something like this. One particular cell, we call it a pixel. Now, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 1, 2, 3, 4, 5, 6, 7. Okay, something like this. Now, anyway, in our system, origin is here. Okay, origin is here, and always when we want to display something, coordinates are integers. Okay, 5, 3. 5, 3 pixel, 5, 3 pixel, it is this one. Okay, always these values are integers. Therefore, the purpose of Dpx function is we round. When we do certain calculations using our program, then we will get fractional numbers to the coordinates. To the x coordinate, we may get a fractional number. But when we try to display it, we have to round it to its nearest integer. Okay, so therefore we use dpx function, and again dpy is used to round y coordinates. Not only that, okay, there is another purpose in our dpy function. Let me explain that one. Not only rounding, int dpy double y, here we have int p, p we assign int as in previous situation here y plus 0.5. In addition to that, we do some extra thing. Here we call an inbuilt function get max y, a graphics function get max y, and from that we reduce p, and here then we return the value of p. Okay, so up to this part now it's clear to you. Okay, so what is the purpose of this part? And here get max y function, get max y function, and also there is another function get max x. Okay, these functions will return the number of get max y will return the number of rows, get max x will return the number of columns. In this situation, let's say now the reason is, now let's say now origin is here, origin is here, actual coordinate 5 comma, this one is 5 comma 3 then, okay. But if you want to consider origin as here, okay, if you want to consider origin as here, what is this? Now this one is 3. No, this one is always 5. 5 is okay. This one is okay. Here also x coordinate. Now if origin is here, now this is our new x axis and this is our new y axis. It is in this direction. So now x coordinate no change. It is okay, but y it is not 3. It should be actually here it should be, if this is the origin 0 1 2 3 4, 0 1 2 3 4, okay, 4. If this is the origin, not in this direction you have to count. And now 4. Therefore, the purpose of this one is we get the maximum value and reduce P. And according to this example, get max y will return the maximum index 7. It will return 7. Get max x will return 10. Okay, and this in this situation, now our new coordinate, if you think this is the origin, x has no change to x, but y coordinate we have to compute it from the max y value. Max y value is 7. If origin was here, coordinate is 3, we reduce 3 and then 4. In this way you have to compute. Okay, so we perform this step to bring the origin from here to here. Okay, we get the max y value and subtract the y coordinate from that. Okay, so now I hope this part is clear to you. Then I summarize these two functions. Now in our graphics system, origin is here. Origin is here, x-axis is here, and y-axis is here. Okay, but we want to bring the origin to here. Then x-axis, our new axis is here, new y-axis is here. Okay, so therefore we use dpx function and dpy function. One particular purpose of these two functions is if we compute a particular coordinate 3.28 4.79, okay, and in graphics display we have always integer coordinates, therefore we have to convert this to integers. When you perform this, it's better you round them to nearest integer, then only we can have more accuracy in approximation. Okay, so here 3 will be, if we apply dpx to the x coordinate, we apply dpx function, then we get 3. For y coordinate we apply dpy function, then first it will become 5 with respect to this origin, and let's say maximum index is 100. Okay, So here initially it will here this will become 5, okay, with respect to this origin. Understood? With respect to this origin it is 5. Let's say there are the maximum index of our rows is 100. In earlier situation it is 3 comma 5 somewhere here with respect to this origin, but we want to take it with respect to this origin. Therefore x coordinate no change, y coordinate we have to consider from this amount, you have to reduce this amount, okay. 100 minus 5, 95. Then this with respect to this origin the value is 95, okay. In that way, very simple thing, anyway you have to understand it. Now we move on to another function. Now that is draw polygon function void draw polygon. Here we have int o, this is o, okay, and we have the body, okay. So now earlier I told you that we will be dealing with two squares and I gave indices to them, this one 0, this one 1, okay. Likewise if we have many polygons, many squares, 0, 1, 2, 3, 4, 5, likewise any number of squares you can represent in this way. However, when you use the draw polygon, the purpose of this function is to draw the square or the polygon on our screen. So here we pass the index of the polygon. If you want to draw this one, here we pass 0. If you want to draw this one, here we pass 1, okay. So here we have to pass the index of polygon, okay, index of polygon. Now let's try to understand how it works. And here let's say now this is our the index of this one is this one index is, let's say for an example index of this one is 0, okay. And now this is our 0, 1, 2, 3 vertices. Now we have stored these 4 vertices in a in an order in those arrays. Now here we have a for loop, okay, when I equals 0, when I equals 0. Now here we have not yet drawn this, no, we have stored only the vertices in the arrays. We have stored only the vertices in our arrays. We have not yet drawn this. Now if we invoke draw polygon function, we invoke inside our main method, we invoke draw polygon function and pass 0, okay. So in that situation, point 0 means now point 0 not point 0, not points O. O will give us the value we have stored in points 0 here. Okay. Now in this situation it is 4, no? Since this is a square. Okay, now here we come to this position, then j equals 0 plus 1, 4. Okay, and this one is the modulo operator in C programming. This operator, if we apply this particular operators, for an example 5 modulo 3, meaning of this one is we have to return the remainder after dividing 5 by 3. For an example, you get this 5 3 1, remainder is 2. Value of this one is 2. Okay, something like that. This is called the modulo operator. Now you will understand why I have used modulo operator in this particular function. So here now what is the value of this one? 1 modulo 4, no? 1 modulo 4 means what? 1 4 0 0 1. 1 is the remainder. This is 1. J is 1. Okay. So in this situation we invoke this line function. Actually now earlier I told you we had included this particular header file, a user defined header file. Inside this header file we have defined this line function. Okay, inside this header file we have this line function. There are 4 parameters. Here you have to pass in these two, you have to pass the coordinates of one particular endpoint. Okay, if you have a line like this, x1 comma y1, x2 comma y2. Okay, so here you have to pass x2, here you have to pass x1, then y1, here you have to pass x2, y2. Here you have to pass x1, then here y1, here x2, here y2. In that way, now there are 2 endpoints, one particular endpoint here, the other endpoint here. Okay, this line function is defined in grep.h header file. Now we invoke this, and before that, before we pass coordinates, we always pass it to the dpx function and return value we put here. Okay, and this one also to the dpy function, then we return value, dpx function, dpy value, dpy function. So the purpose is clear. First thing is, to the line function, that this function deals with graphics display, and its argument should be integer values. Therefore we first round those values to the nearest integers. That is why we have used dpx and dpy functions. And using dpy function, in addition to rounding, it changes the origin, as I have discussed earlier. Okay, now here however, here we pass 0 I, not 0, oi here. Okay, oi, then here oj. Okay, that means here we have used our zeroth polygon, and now here our I is, in this particular situation our I is 0, and in this particular situation our j is 1. Therefore 0 and 1 we draw. Okay, we draw this particular line segment, and then in the loop we come to the next one, I equals 1. There j equals 1 plus 1 modulo 4, 2 modulo 4. Okay, 2 modulo 4 means if you divide 2 by 4, this is 0, remainder is 2. This one is 2. Now, if you look at the line function, here we pass, now I value is 1, j value is 2. So we draw this particular line segment, and next one I equals 2, then j becomes 2 plus 1 modulo 4. 3 modulo 4 means we divide 3 by 4, 0, the remainder is 3. Here we have 3. Okay, now we move to the line function. Here I equals 2 now, and j equals 3. Therefore 2 and 3, this line segment will be drawn. And now we move to the next one, I equals 3. There we have 3 plus 1 modulo 4. 4 modulo 4. What is the value? If we divide 4 by 4, 1, remainder is 0. The value is 0. Therefore, now if you look at the line function, here I is 3 and j is 0. 3 and 0. Now using this particular one, now I hope you have understood why I have used modulo operator here. Okay, in order to connect this vertex with this one. Okay, so you have to think again. Okay, you can pause the video and think again and try to understand. Okay. And now we want to discuss a particular function, void translate int o, int I, double t. Just space is not enough, so void, okay, void translate int o, int I, double tx, double ty. Okay, so this function, anyway, I will write the body as well. 0 O, this is O, okay. I plus equal. This is an abbreviated notation. I hope you are familiar with this one. Okay. Y0 I dy. The purpose of this particular function is to translate a particular vertex of a polygon. Now, if it is our spheroid square and 0, 1, 2, 3, let's say in spheroid square third vertex. Therefore, here you put our two value O, that is 0. Okay, I means 3. I means 3. Okay, so let's say coordinates of this one is, coordinates of this point is 7, 5. Okay, and let's say here we put 2 and 3. We pass 2 and 3. Okay, then what happens? If we pass 2 and 3, then what happens? Here to 0, 3, we add Tx amount. That means 7 plus 2, 9. Here to y, we add Ty amount, 5 plus 3, 8. Therefore, if we invoke this particular function, okay, in this way, translate our 0, 3 to 3. In this particular situation, this particular vertex will change to 9 and 8. Okay, so in that way we can use this translate function. What you have to understand is, here we always apply this function to a single point. Okay, that means this vertex or any other vertex, you can apply this particular function. Now we move to another function, void rotate int O int I double T, and here body goes. Okay, now purpose of this particular function is, here we pass which polygon, the index of the polygon, then which vertex. This is the amount that should be rotated around the origin. Okay, the amount. Now we have a particular vertex. Okay, so around the origin, the angle rotated around the origin, the angle you have to pass here in radians. Okay, in radians you have to pass the angle. If we pass three, that means 60 degrees. Okay, in that way you have to pass it in radians. Now let's try to understand the body. Before we understand, I just want to do some mathematical calculations. So this is the origin. This is the origin, and here you have the point, okay, and we rotate it around an angle theta. We come here x1 y1. After rotating this particular point around the origin by an angle of theta, we come to this position, okay. So now if this length is r, this length is r, this length is also r. So if you consider this particular triangle, then what can we say? And let's take this as alpha. This length is r cos alpha, this length r sin alpha, okay. And now if you consider this particular, so first if you consider this particular triangle, now this length, in other words, this is x, okay. So x means r cos alpha. This one, in other words, it's y. Y means r sin alpha. Now if you consider this particular triangle, so x1 means this length means actually r cos theta plus alpha, r cos theta plus alpha, this length. If you consider this particular triangle, r cos theta plus alpha, okay. X1 means, now y1 means this length, it is, if you consider this particular triangle, r sin theta plus alpha, r sin theta plus alpha, okay. So if you consider these two, first one, let's consider x1, then we can expand it like this: cos theta cos alpha minus sin theta sin alpha, okay. And now here we take r cos alpha cos theta minus r sin alpha sin theta, okay. So now r cos alpha means x, okay, r cos alpha means x. R sin alpha means y. Now here cos theta minus y sin theta. Now if you consider this particular one, y1 means r sin theta cos alpha plus cos theta sin alpha. Now here r cos alpha sin theta plus r sin alpha cos theta, okay. So here r cos alpha means x sin theta plus r sin alpha means y cos theta, okay. So Now you know, simply if you consider, now you know, if this is our coordinate system, if you have a particular point x comma y, if we rotate it around the origin in anti-clockwise direction, so the coordinates of this one x coordinate is x cos theta minus y sin theta, y coordinate of this point is x sin theta plus y cos theta. Okay, so that is the summary. So here I just write down the summary of our mathematical derivation. Here x1 means x cos theta minus y sin theta, y1 means x sin theta plus y cos theta. This is the summary of what we have done. Okay, so now if you look at the rotate function, the purpose is, this is the index of the polygon, this is the index of the vertex, so altogether this part represents a particular point. Here we specify the angle in radians. Okay, so now here now you can see, this one I will explain later. Now here you see these equations. To this one we have here original coordinates. Now our, if you consider our point here, this is our O and I, Y, O and I. This is the coordinates of this particular point. So now you want to assign these two arrays, you want to assign the coordinates of this particular point after rotating it in anti-clockwise order by an angle of theta. Okay, so here you now, to this array, okay, array element, not just let's write it in this way. Okay, you have two values. Now these are the O I, Y O I, this one, this value here, this value here. Okay, now we want to replace the value of this one from this and value of this one from this. Okay, so in order to do that, first we assign the values in x1 and y1, x1 and y1 coordinates. So don't mess up with this x1 and y1. Okay, so let's say here let's put x new and y new. Okay, otherwise you will mess up this y1 and x1 with this one. Okay, so now here these two values, we assign the original values to these two. Okay, after that we perform these two. Here previous x coordinate cos theta minus previous y coordinate sin theta. Here previous x coordinate sin theta plus previous y coordinate cos theta. Okay, So the reason I have assigned rather than putting here, why haven't I put this one directly here? Okay, instead I have assigned these two values to variables, and after that I have substituted those variables here. Okay, what is the purpose of doing that? What is the purpose? Now you have to think. You have to think. You can pause the video and think. Okay, you have to pause the video and think. The reason is, so if I didn't use this one, if I used original values, let's say, then this value is changed. Now this value will be changed when I perform this particular operation. Then if I put, instead of here x1, if I put this particular value, it will apply the changed value here, not the original value. So you will get an erroneous result to this coordinate. Understood? I will explain it again. So the reason is, what we want to explain is, here instead of assigning these values to separate variables, why haven't I used xoi here, then yoi here, xoi here, and yoi here? Why haven't I done that? That is the question, that is the problem. Okay, the reason is, now if you when you compute this line of code without any problem, the new value of this one will be computed. But when we try to compute this one here, then we are going to use the new value of xoi, not the previous value. But actually we have to use the previous value according to these two equations. Here you have to use the previous x coordinate of the original point. But here, if we directly use these values, here we would use the new x coordinate. So that will give us erroneous results. Therefore, first we assign the coordinate to x1 and y1, then perform the calculations. Okay, now think about it again and try to understand. Okay, so that is about rotate function. Then another function, f rotate, void f. Here from f I just denote fixed. Okay, fixed rotate, fixed. Okay, so f rotate is here void f rotate. Here we have int o, int I, double t, double x, double y. Sorry. Okay, this is our function. Body goes here. Okay, so now body goes here. Now if you look at rotate function, the previous I discussed rotate function, and there what we did was we rotated the point around the origin. If you apply to a particular point, if we apply rotate function, okay, if we apply rotate function, let's say by an angle theta, then it will rotate around the origin. It will rotate by an angle of theta in anticlockwise direction. Now let's say not the origin, around this particular point we have to rotate another point. This point we want to rotate around this particular point by an angle of theta. Here we have used t, okay, because in C programming we do not have theta, okay. So anyway, now we want to rotate around this by an angle of theta. Okay, now we want to find the coordinates of this particular point. Then now how can we do this? Now we know rotate function. Okay, we know rotate function. Okay, using this one we can rotate around the origin, but here we have to need to rotate around x comma y. Now how can we do this? How can we do this? One particular way, okay, one particular way here in this body we have done that. First we translate, okay, first we translate o comma I minus x minus y. Then in this situation what is going to happen? Minus x comma minus y. Then that means this particular point we translate amount is minus x and minus y. Minus x amount along the x direction and minus y amount along the y direction. Okay, so then this point will come to here. Understood? Now let's say this is our point Q, this is P, this is R. Okay, now Q comes here, Q's first position. Now P is here. First we translate P1, let's say P1. Okay, now our point is here after applying this particular operation. Then rotate OIT. What happens? Then after that, here this point will be rotated around the origin by an angle T in radians. Okay, so here it yes, it comes here. T. It comes here. Okay. Now we have computed this coordinate. Now again we are going to shift this to its original position. Again we translate OIXY. OIXY, that means we translate again Q this one goes here, okay, this one goes here, and this one goes here, okay. That means now after these three operations we have computed the coordinates of this particular point, okay. So that is called fixed rotation. Here you have to pass the index of our polygon, then index of the vertex, the angle in anti-clockwise direction, here x coordinate and y coordinate of the fixed point of our interest, okay. So this fixed point usually we call it pivot point, okay, pivot point. Around that particular point we rotate, okay. So then I hope this part is clear to you. Then we move to another function that is called scale, void scale double sx okay. Now here what we do is here this is the index of the polygon, then this is the index of the vertex. This amount and this amount, we specify two amounts, and here what we do is x coordinate we multiply from the value of sx, and then y coordinate we multiply from sy, okay. So it is something like this. If our coordinate is 2, 3, and if sx is 4 and sy is 5, then what happens? After execution of this scale function for this particular point, then this will become 2 into 4, this will x coordinate will be 8, y coordinate will be 15, 8, 15, 8, 15, let's say somewhere here, okay. So this scaling, we say the scaling has been done with respect to the origin. With respect to the origin we have scaled, okay, with respect to the origin, because this coordinate with respect to the origin, okay. So then let's move to the next function. Void f scale int o int I. Yes, space is not enough, so I rewrite this void f scale int o int I, okay. Then double sx double sy double x double y, okay. This is our body goes here, Okay, this is our f scale function. Here also f I have meant from f fixed. Fixed means with respect to a pivot point we scale as in rotation. Okay, so here what we do is, let's say with respect to this particular point we want to scale this point with respect to this particular point. Okay, as in rotation you have to understand, first you have to translate o comma I minus x minus y. Okay, so here this one we translate this to here, then this will come to here. Okay, this to here, because here we have minus x minus y, definitely this will come to the origin, then this will come to somewhere here if you move this, and now we scale. Now we use scale function. Scale function is with respect to the origin. So we invoke the scale function and 0 comma sx amount and sy amount. Okay, so now here we scale, let's say it went somewhere here. Now again we have to push this to the original position. Now translate 0, no not 0, o I x y. So this one, now we put here our new position will be somewhere here. Okay, here compare this one with rotation. Compare this one with rotation, and then you will understand. Scale function is with respect to the origin. If we want to scale with respect to a pivot point, in that situation, first we have to move it to the origin, then perform scale, and then after that move it back to the original place. Okay, that's what you have done. So again you can pause the video and think. Okay, so this is logical. So in this video I do not give you time to think, but it's your responsibility. You pause the video and think. Okay, now now we discuss the main function of this our C program. Now here we declare two integer variables, Ginit function, that is yes, Ginit. Okay, this function actually this function is declared inside this particular header file. Okay, so the purpose of this function is to initialize graphics. Okay, so if you work with your own program, you do not have to worry about this particular function. Okay, just to initialize graphics. And now here we put values. Now let's consider our coordinate system x, y. Here we have the origin, now minus comma minus 5, one particular, this is our zeroth. Here from this particular 0 we can understand that Anyway, now I told you earlier the arrays we have declared, we are going to store squares in those arrays. Okay, so here this is our spheroid square or rectangle. In this particular example, I am using squares, and here x0 means the coordinates of spheroid vertex. Okay, spheroid vertex, x coordinate is -5, and here y coordinate is -5. Then here the next one 1. Okay, 1. X coordinate is 5, then y coordinate is -5, then 2 means x coordinate is 5, y coordinate is 5. Here 3 means this one yes, x coordinate is -5, y coordinate is 5. Okay, so let's yes, now if you draw this one, now again here point 0 is 4, the number of vertices is 4. Now here if I draw this, it is something like this. Okay, here we have 5, 5, -5, 5. Okay, the square is something like this, you know, -5. Okay, square is something like this. So we have stored that particular square, and index of this particular square is yes, not I just use an array. Index of this particular square is 0. Okay, now we move to here. We use a for loop and copy. We use a for loop and we copy x coordinates to an x, y coordinates of our zeroth one to 1. That means we create another square with the same coordinates. We have copied another copy. Now on top of this we have another square. Square means actually we have stored the 4 vertices in the arrays. Now 0 as well as 1, both squares are here. Actually we have stored vertices in the arrays. Okay, that is the meaning. And now here points 1 variable also we put 4, because in this situation we have 4 vertices. Now yes, this one -5. Okay, -5, 5, -5, 5. -5. Then we use a for loop. Use a for loop because there are 4 points, 4 vertices in one particular square, and we use the translate function to zeroth square. So we translate it in the amount 150. Tx is 150 and Ty is 250. Okay, those are the two values. Okay, those are the two values. So That means easily you can understand this will you move to somewhere here, okay, somewhere here. We move one particular 0 1, 0 index 1, now it is here. Here now we have applied now its center. If you consider now here center is the origin, no? Center will be 150 and here 250. They are not in the scale, okay, so not in the scale, so don't worry about that, okay. So these coordinates are not in the same scale, but for the simplicity I just have represented, okay, 5 and 150. Don't worry about that one, okay, just worry about the figures, okay, not the scale. Now here that means if you translate each vertex, this will move to here, this will, using a for loop we do that, no, okay. We put I begins from 0, this was the 0, no, 0 to here, okay, in one particular iteration. Then in next iteration this to here, this to here, and this to here. Now it is here. So logically if you try to if you think thoroughly, then you can understand origin. Now since this is an square, now this is the center of the square is also the origin, okay. So it is a square, no? Therefore center is the origin, these lengths are equal, no? Therefore center is the origin. So here now origin, now the coordinates of origin is here, okay. So that one you have to logically understand. In the same way you apply another for loop and this one you move to somewhere here. Okay, so here I have used 450 here, then 250 here. Now this is our 1, okay. Now in this way we have, they are not in the scale, these values, okay. So don't worry about that, don't okay. So here we have now the two squares are located in this way in our coordinate system, okay. In our coordinate system these two squares are like this, okay. Then let's move to this part. We have a for loop, then 500 times we iterate, set color 15. Set color 15 means in this particular compiler we have used 15 means actually white, okay. The background color of our graphics screen is black, so we try to draw the squares using white color, okay. So now we, let's say this is our graphics screen, then we invoke draw polygon 0 means this one will be drawn, let's say somewhere here this one will be drawn. And if we invoke this one will be drawn somewhere here, okay. They are not in the scale, but don't worry, just roughly I will try to get the same size, but don't worry, okay. So now we have a delay 200 means 200 milliseconds of delay. That means we have drawn the two squares, then we wait 200 milliseconds until we come to the next line of code. Then here set color. Now set color, I have told you the background of our graphics screen is black. That means number is 0. The lines we draw in white, number is 15. This is black, this is white. Okay, so after that we set the color to 0, that means black. Again we redraw the two polygons. Understood? We draw the polygons, then we wait 200 milliseconds, then we redraw the polygons using black color. That means initially when you draw, you know that the background is black. When initially you draw these two polygons, they are drawn in white color. Now we redraw them in black color. That means, in other words, we erase the two polygons. Okay, so white color. Now again I will explain. The background color is black. Okay, so we set the color to white and then draw the two polygons. Then we wait 200 milliseconds. After that we set the color to black and redraw the polygons in black color. Okay, here we draw the polygons in white color, then you will see it in the black background. Here you redraw the polygons using black color. That means the process is similar to you have deleted the two polygons. You have erased the two polygons. Okay, that is a simple thing when we deal with graphics. Then here what we do is we have for loop. Okay, there we apply it to each of the four vertices. Then we apply fixed rotate. Now the coordinates of this one is 150 and 250. Here you know this is 450. Now we apply fixed rotate function. If you consider we apply fixed rotate function. The angle is 0.1 radians in anti-clockwise direction. This anti-clockwise direction. Okay, so 0.1 we apply. So in each iteration there are 4 iterations. No, so here we have 0, 1, 2, 3. Therefore each vertex will be rotated in this way. Okay, by an angle of 0.1 radians will be rotated in anti-clockwise direction. Okay, anti-clockwise direction, this direction, anti-clockwise direction. Now again we consider that is our spheroid one. This is our spheroid polygon. No, this is index of this one is 1. Now we focus on this one. They are minus 0.1 rads, means rotation is performed in clockwise direction. Now if you put a positive value, rotation is performed in anti-clockwise direction. If you put a negative value, the rotation is performed in clockwise direction. Clockwise. Okay. Now here around this point, this is this pivot point, therefore we have new position will be like this. They are not in the scale. Okay, so don't worry about that. just try to understand the logic. Not only that, so actually we perform this vertex wise, but when I explain, I just use now. If you scale, then again this is scaled, not only rotated, but it is scaled by amount 1.005 scaling factor. Both the scaling factors of Sx and xy, scaling factors, the same value we use. So this will be little bit scaled, not this one then, okay. So something like this. This one also will be enlarged because it is 1 point something, okay. It will be enlarged, and this one also we perform the same. Yes, for both we perform scaling, okay. Therefore what you see now, that in that way, actually in one particular iteration we apply the operation to a single vertex, but since we apply the same process to all four vertices, you will see like this. And again we perform this one again. This is a for loop. No, again we come to here. From the white color you draw the polygon, then we wait 200 milliseconds. Again black color we draw the polygon. In other words, we draw the polygons, then we erase the polygons, okay. Then again we perform this operation. Again we come here, draw the polygons, then wait and delete the polygons. Again we perform the operation, and something like that. So therefore altogether we have 500 iterations, but we can put any number here, or we can put an infinite loop here. Anyway, what you see here is this will be rotating and enlarging. While rotating, it will be the square will be rotated in anti-clockwise direction around this vertex. While rotating, it will be enlarged. Okay, this square is also rotating around this particular point. Then while rotating, it will be enlarged. Okay, in that way you will see something like that. So you try to implement it, C or use any other programming language you are familiar, then try to get this particular output, okay. So and here getch function you are already familiar. Gexit means actually that is also defined in grep.h header file, okay. So ginit, we initialize graphics. From gexit we have ended graphics, okay. That's what we have done. Now now I hope you have clearly understood, okay. Clearly understood rotation and scaling of polygons. If you have this knowledge, you can do very nice things in computer graphics, okay. So if you could understand the content properly, you can give me some help. So one thing is you can put a like to this video and put a comment, okay. Any comment you like, okay. If you have any questions, you can mention them in the comment section, and share this in your social media profiles, okay, so that this video is seen by many people. And I request you to subscribe the channel, and also then finally thank you for watching the video.